Hi, my dear children. Today I will be going to explain you the hybridization of carbon atom further. So there are three types of hybridizations of carbon atom. I had explained two types of hybridizations. First one is sp3 hybridization of carbon atom. Then the second type is sp2. I had explained last day. I will remind these two again little, right? See here, this is the sp3 hybridized carbon atom. sp3 hybridized carbon atom, right? So this carbon atom has four sigma covalent bonds. Four sigma covalent bonds. So they are formed by the linear overlapping of sp3 hybridized 4 orbitals with atomic orbitals of hydrogen atom. Right? So what is the shape of this arrangement? This is the shape of tetrahedral. sp3 gives the tetrahedral arrangement. There is the bond angle 109.5. All the angles are similar. So this is the characteristics of sp3 hybridized carbon atom. It forms 4 sigma covalent bonds to give the tetrahedral shape, giving the angle 109.5. Right? Then, last day I came to the sp2 type of hybridization. This is the model of the sp2 hybridized molecule of carbon atoms. Right? So these two carbon atoms are sp2. See here, 2 sigma covalent bonds. sp2 hybridized one orbital, sp2 hybridized other orbital. They form 1s atomic orbital of hydrogen, linear overlapping. They form 2 sigma covalent bonds. Similarly, here also sp2 hybridized carbon atom, it also forms sigma covalent bonds, 2 sigma covalent bonds with 2 hydrogen atoms. Then these two are sp2 hybridized carbon atoms. So between the two carbon atoms there is a double bond. What do you call? Double bond. 2 bonds, double bond. Then you must know that always double bond consists of sigma bond and phi bond. Sigma bond and phi bond. Sigma bond is formed due to the linear overlapping of sp2 hybridized orbital of this carbon atom, sp2 hybridized orbital of other carbon atom. They are linearly overlapping. This is the sigma covalent bond. So do you remember I explained you the sp2 hybridized carbon atom has 1, 2, 3 hybridized orbitals at the same plane. These two, and the other one is this one. Similarly, this carbon atom also having 1, 2, 3. These two of the 2 carbon atoms are linearly overlap to give the sigma covalent bond between the 2 carbon atoms. So other bond, it is 5 covalent bond. How it forms? Do you remember? sp2 hybridized carbon atom has unhybridized p orbital perpendicular to the plane. This also having unhybridized p orbital with the dumbbell shape. This also having unhybridized p orbital with the dumbbell shape. So they are unable to form sigma covalent bonds with other atoms. So they laterally overlapped to give the 5 covalent bond. So the one bond is 5 covalent bond. 5 covalent bond is always formed with the unhybridized orbitals due to the lateral overlapping. If it's so, this is the simplest molecule of sp2 hybridized 2 carbon atoms are formed. C2H4. It has the shape. What is the shape? These two with carbon and the other two with carbon all lie the same plane. The 5 bonds also between these two atoms. What is the angle? 120. 120 angles. These two are. Right? This is the sp2 hybridized 2 atoms. They are formed the simplest molecule. What do you call? Ethane. Right? Then, today, I will be going to explain you other type of hybridization. Right? Then, see here, this is our former diagram. Energy axis 2s, 2, 2p, 2. Carbon atom has the second energy level 2s2, 2p2. So 2s2, 2 electrons in the spherical orbital. The higher energy level, there are dumbbell shaped 3 orbitals. Dumbbell shaped 3 orbitals. One here, other one here. 2 electrons, one is empty. This is the ground state configuration. 2s2, 2p2. Right? Then, before the formation of compound, do you remember, it becomes to the excited state. How? One electron of the 2s orbital transfer to the empty orbital, empty p orbital. So, this can be represented as one electron here. No, nothing happened, any other changes. Then, these are the 3 dumbbell shaped orbitals. Now, these are the initial 2 electrons. This is the electron came from 2s. Now, carbon has 1, 2, 3, 4 orbitals, s orbital and 3p orbitals, having 1 electron in each. But these are at the two energy levels with two shapes. These three are dumbbell, this is spherical, right? Then, after the exciter state, what is the configuration? 2s1, 2p3, 2s1, 2p3. Then, do you remember sp3 hybridization? All the three orbitals come down little, that s orbital goes above little, they come to the common energy level, forming four identical orbitals. This is the sp3 hybridization, right? Then, out of these three orbitals, only two come to little down, S goes up, they come to the common energy level, forming identical three orbitals. It is the sp2 hybridization. So it is unhybridized p orbital. I think. Do you remember it? Right? I had explained by my fifth video. Then, in this case, only out of the three p orbitals, one orbital comes down little. One orbital only comes down little, then s orbital goes up to meet at the level, common energy level, forming identical two orbitals with the same shape and same energy, reducing the one lobe of p orbital. Then, in this case, one s orbital mixed with one p orbital. So what do you call that type of hybridization? S.P. hybridization. S.P. hybridization. Right? This is the third type of hybridization. Then this carbon atom has only one comes down, so these two are at the same energy level. So, sp hybridized carbon atom has unhybridized 2p orbitals with the dumbbell shape at the higher original energy level. This is the sp hybridization. Right? You understood? So, then our problem is how these four orbitals are arranged around the nucleus of carbon atom. I'll explain you. It is clear. If all the three come down with s orbital, sp3, out of the three, only two come down with s orbital, sp2. In this case, out of the three, only one comes with sp. It has unhybridized 2p orbitals with dumbbell shape. These are hybridized orbitals mixing S character and P character. They give the different identical orbitals. Right? Then I explain you how these four orbitals are arranged around the nucleus of carbon. Right. Right. This is the carbon atom. Nucleus of the carbon atom. Or write a positive nucleus of the carbon atom, which undergoes S.p. hybridization. So, hybridized two orbitals are arranged opposite to each other. Opposite to each other. These are the two sp2 hybridized orbitals. What is the angle between? 180 degrees. sp. It is named as the arrangement, linear arrangement. Linear arrangement. Then other two are arranged perpendicular to one unhybridized p orbital. Arranged. It has two lobes. The electron arranged perpendicular to that plane. Perpendicular to that plane. So, where the other one? Other one arranged perpendicular to the horizontal line, vertical line. This is the axis of the other unhybridized p orbital. So it arranged like this. I said to identify different each other. This also having an electron. This is the arrangement. This is the arrangement. Right? So, now I can show you right. I draw the orbital diagram. These two are sp hybridized two orbitals with angle 180. These two are the unhybridized p orbitals. How many p orbitals? Unhybridized? Two p orbitals. This is one orbital, the other one. These two, they are having two lobes of the dumbbell shape. They are original dumbbell shape. Then I'll show you roughly the arrangement. So see here, if this is the hybridized 2p orbitals. These are the hybridized 2p orbitals with 180 angles. So this is the unhybridized p orbital perpendicular to these two. Where are the other ones? This one It is not like this. It is, this is the arrangement. This is the arrangement. This is the arrangement of this orbital. This is the arrangement. Right? So see here, all are perpendicular to each other. This is the arrangement. This is the arrangement. Right? So these two are the sp2 hybridized 2p orbitals, sp hybridized p orbitals. This is vertical, this is the other one perpendicular to vertical plane. This is the angle. This is the hybridized orbital, unhybridized orbital. Right? This is the arrangement. This is the arrangement. Then, do you remember, for the formation of sigma covalent bonds, only undergo hybridized orbitals. Then, see here, as in the case of sp2 hybridized carbon atom, this also unable to come to the octet completion alone, because really it has formed only two bonds. I told you that unhybridized p orbitals do not participate for the formation of sigma covalent bonds. Right? Then if this one combines with H atom, this also with other H atom, C1, 2 H atoms, CH2, no compound, CH2 no compound. So, as in the case of sp2 hybridization, do you remember, before the formation of molecule, sp2 hybridized two carbon atoms get joined each other with the sigma covalent bond through the sp2 hybridized orbitals. Similarly, here also it occurs. I draw here the other sp hybridized carbon atom. Now it also having like this hybridized sp hybridized orbital. Then these are linearly overlapping, forming sigma covalent bond. So the other sp hybridized carbon orbital is here. These are other sp hybridized orbital of this carbon atom. Thus, two carbon atoms are joined each other with the sigma covalent bond together. Then this one also having unhybridized 2p orbitals, which are perpendicular to each other. Then see here, this is the one sp unhybridized p orbital. It becomes parallel to this one. These two are parallel to each other. Similarly, the other orbital, it is perpendicular to this vertical plane. This is the other orbital unhybridized. Right? I think if I draw like this, you can understand very clearly, because you must know how to draw the molecule. So it is clear that these two planes are parallel to each other. These two planes also parallel to each other. Then these two are overlap laterally. Overlap laterally. Because they close to each other. Close to each other. So it is unable to show diagrammatically. Similarly, these two also parallel to each other, they also overlap laterally. Right? Then it is clear that due to the unhybridized p orbitals with the lateral overlapping, what type of bond is formed? 5 type of bond is formed. 5 covalent bond. Here also same. Due to the lateral overlapping of these two orbitals, here also formed 5 covalent bond. So it is clear that between the two carbon atoms, one sigma bond with the linear overlapping of sp hybridized orbitals. Then two 5 bonds, one 5 bond here, other 5 bond here. These are the two 5 bonds between the two carbon atoms. So it is clear that these two 5 bonds are at two planes. It is clear, I think. This is the plane of this 5 bond. This is the plane of this 5 bond. So here 5 bond, here 5 bond. 5 bond, 5 bond. They are having 90 degrees each other. Then, after that, two H atoms come here. H atoms, one s orbital. So, atomic orbital, we know that hybridized orbital undergoes one s orbital of hydrogen linear overlapping, forming sigma covalent bond. Here also, H atom, one s orbital, linear overlapping, forming a bond. This is the sigma covalent bond. So, these two carbon atoms form two sigma bonds with two H atoms. This is the molecule which forms after the two carbon atoms undergo sp hybridization and combine with two H atoms. Now see here, this bond is electron pair. The 5 bonds are also electron pairs, two electron pairs, 1, 2, 3, 4, it gets completed octet. This also same, completed octet. Then there is a triple bond between the two carbon atoms, triple bond. So it is clear that triple bond means 3 bonds. Out of the 3 bonds, one is sigma, other 2 are 5 bonds. Sigma bond is formed due to the linear overlapping of sp hybridized orbitals of two carbon atoms. 5 bonds are formed due to the lateral overlapping of unhybridized p orbitals of both carbon atoms. Right? Then, what is the shape of this molecule? Linear. The shape is linear. Now it is clear that sp3 hybridization, the carbon atom has the tetrahedral arrangement. All are covalent, sigma covalent bonds. sp2 only 3 sigma covalent bonds with 1 pi bond. It is plain, triangular, plane, and having the shape trigonal plane. Trigonal plane. This is sp hybridization. It has the shape linear. It has the shape linear. sp3 needs for the completion of octet, it is possible to form by one carbon atom for the saturation of octet. But sp2, the two carbon atoms should be bonded to each other before the formation of other two bonds. As I explained you last day. Today, sp hybridization, it is clear that two carbon atoms, they form a sigma covalent bond with other two H atoms. There are 2 pi bonds, right? Then these are the types of hybridization of carbon atom. What do you call? sp3 hybridization, sp2 hybridization, and sp hybridization. These are the three types of the hybridizations of carbon atom. Then, by my next video, I hope to explain you what are the differences between sigma covalent bonds and phi covalent bonds, about their energy and structure and other properties also. Right? Then, thank you very much. So, I will meet you next day.